Today we're going to skip over lesson 2.2 for now and look at lesson 2.3, and this is going to be dealing with something called direct variation. So direct variation is a linear function that is defined by an equation y equals kx. This right here is the generic formula for direct variation, and it's important to note that k is a constant. It is, you see it here defined, constant of variation. It's the value of k in direct variation. So this is a number. It could be a number like 5. It could be a number like negative 2.7. It can be any number. It just can't be 0. The reason it can't be 0 is because if it was 0, we would have 0 times x, and we would just have y equals 0, and it would not be effective. The y-intercept of a direct variation equation will always be what? Thinking about this equation and what we know about linear equations, we should remember, hopefully, if not, we'll review it tomorrow. We should remember that the number in front of x represents the slope, and the number that's added on to the end is the y-intercept. But in this case, there's nothing added on, so the y-intercept of a direct variation equation will always be 0 every single time. So, determine whether the following tables represent direct variation. If it does, find the constant of variation and write the equation. So the way that I'm going to figure this out is if I think about my formula for direct variation, it's saying that if I take any value of x, I can multiply it by the same number, whether it's 5 or negative 2.7 or anything else other than 0, I will get a number. So I'm going to look at each of these x values and say, how do I get from 1 to 3? To get from 1 to 3, I have to multiply by 3. I could also add 2, but that would not work for the rest of these. If I check here, if I said what's 2 plus 2, I would get 4 instead of 6. So I'm going to say, oh, look, I can multiply each of these by 3. So I can say, yes, this is a direct variation because the constant of variation, or the COV, is 3. I'm multiplying each of the x values by 3 to get the y value. If I look here, I'm going to have to get from 3 to 18, I would multiply by 6. 4 times 24 is also, 4 times 6 is 24, but I multiply by 6 as well. But here it doesn't work. If I try this, if I try to do 7 times 6, this one is not going to work. So this is not direct variation. It has to work for all of them. So determine whether the following functions are examples of direct variation. So direct variation looks like this. Y equals kx, where k is some constant. Now, neither of these at first glance look like this, but let's see what happens if I get y by itself. Because 4 and y are being multiplied together, I can divide both of them and get y equals 3/4 x. This looks like this. They look the same. So I would say yes, it's direct variation, and the constant of variation is 3/4. Here, if I try to get y by itself, I'm going to subtract 7x from both sides. And then I'm going to divide everything by 2. And I would end up with y equals negative 7/2 x plus 4. This, if it stopped right here, it'd be fine. But because it has that plus 4, we say no, it's not direct variation. Now we're going to write our own equation and then use it to find another value. So we're given this to start with. Suppose that y varies directly with x. The minute I read that word directly, I'm thinking y varies, I'm thinking like this. Y varies directly with x. Y equals kx. And here are our starting points. We're given the value of x equals -3 and y equals 10. We are given this because we are going to use these to find our constant of variation. It doesn't change for different values of x. As we saw over here, it has to be the same actually all the way through. So this time we don't know what our constant is, so we're going to use this test point of x equals -3 and y equals 10. So I'm going to substitute those in. I get 10 equals k times x, where x is -3. And then I have to divide both sides by -3. So k equals -10/3. So I'm going to start by writing an equation, a direct variation equation. So I'm going to get y equals -10/3 x, and then I'm going to use this new formula to do the second part. So this was the first, find the equation. The second part is to find x when y equals 2. So I'm going to take this equation and I'm going to substitute in 2 for x, or for y, not for x. So when I want to get rid of a fraction that's being multiplied, I have to divide by that fraction. But really what that means is multiply by its inverse. So I'm going to multiply both sides by -3/10. And so when I write this out, I've got -3/10 times 2/1. These cross out. This becomes a 5. So I would end up with -3/5 equals x. And I could put that over here, but I just like having the x on the left. Over here, they would cancel out. The 3's would cancel, the 10's would cancel, and a negative and a negative make a positive. So that's how I'm going to get -3/5. So I've taken care of both parts. This was part 1, write the equation, and this was part 2, find x. So try this one. Write your equation of y varying with x based on x equals 2 and y equals 7, and then find x when y equals 8. So what we should get is that y varies directly with x. Substituting in these values, I would get 7 equals k times 2. I want to get k by itself, so I'm going to divide both sides by 2. And I'd get k equals 7/2. And it's not really enough just to say that k equals 7/2. We need to really write the equation. Y equals 7/2x. So there's part 1. Part 2 is to find x when y equals 8. So I'm going to have 8 equals 7/2 x. I want to get rid of 7/2, so I'm going to multiply by the reciprocal so that they cross out. And I would get, if I think of this as 8/1, I would get 16/7, and that's what x equals. That's not a pretty fraction, but really that's all you have to do with it. You don't have to take it a step further. You don't need to make it a decimal. You can just leave it 16/7, and that will be perfect. So check out your homework assignment for today, and as always, please let me know if you have any questions.